This first question is a review question. We've done one like this before. Anytime you're given sine, cos, or tan, and they tell you information which can tell you what quadrant it's in, it's a triangle question. So in this situation, cos is equal to 3/8, and it's not in quadrant 1. What quadrant is it in? Quadrant 4. So we can use the cast rule. Right? The cast rule says cos is positive in quadrants 4 and quadrant 1, but it's not in quadrant 1, so it must be in quadrant 4. And so we can draw that angle in quadrant 4, and we can make a triangle. Now you're going to be tempted, which side do you make the triangle back to the x-axis or to the y-axis? Or does it not matter? You have to go back to the x-axis because this is your reference angle. Reference angles are very important, and because that's your reference angle and cos is equal to 3/8, you can label saying the adjacent side is 3, the hypotenuse is 8, as one example of a triangle that could exist in quadrant 4 with that property. A squared plus b squared equals c squared. Like I said, you're going to get really good at mental math with a squared plus b squared equals c squared. What is the length of the other side? Square root of 55. Were you able to get that in that time? Right? What did I do? I just did 64 minus 9. And then square root of that is 55. So find sine of theta. Well, sine of theta is opposite over hypotenuse, and because it's in quadrant 4, sine is negative. Find tan of theta. Well, tan of theta is opposite over adjacent, and because it's in quadrant 4, it's negative. So if you know the quadrant and you know one of the trig ratios, draw a triangle to figure it out. Is this point on the unit circle? Now, the number one mistake that people make in this question is they say, I've memorized my unit circle, and I know those points. Are those the only points on the unit circle? No. Wouldn't you agree that there's a point right there that we have not memorized? We don't even know the coordinates of that one. So we can't just say, no, this isn't one of the ones I've memorized, so it's not on the unit circle. And so the three big ideas that we have in this unit, okay, we learned right away that points on the unit circle are cos theta comma sine theta. That's one of our big ideas. Another big idea that we learned is that points on the unit circle means that sine squared theta plus cos squared theta equals 1. And this is related to the equation of the unit circle, that if a point is on the unit circle, then you have to have the x coordinate squared plus the y coordinate squared equal to 1. Because that's your radius, that's your y coordinate, that's your x coordinate. So we can use this big idea to check. Is this true? So we can evaluate root 3/3 squared using the big idea. And if it's equal to 1, then it's on the unit circle. If it's not equal to 1, then you would say it's not on the unit circle. So we're using our big idea here and applying it to this question. Well, what happens when I square something? That means multiply it by itself. Root 3 times root 3 is just 3. 3 times 3 would be 9. Root 6 times root 6 is 6. 3 times 3 is 9. 3 plus 6, 9 over 9. And so we can say, yes, it is on the unit circle. So this question used two of the big ideas. That points on the unit circle were cos theta comma sine theta, and that sine squared plus cos squared equals 1, or the equation of a circle is x squared plus y squared equals 1. What was the third big idea that we didn't have to use in this one? Just to remind you, third big idea was that tan theta is sine theta over cos theta. If this point, negative 12, 13, comma y, is on the unit circle and it is in quadrant 3, find y. It tells you what quadrant it's in. Pretty. So you know it's in quadrant 3. What also do we know? From our big idea, since it's on the unit circle, we know that cos of theta is negative 12 over 13. So when you know the quadrant and you know one of the trig ratios, you can draw a triangle. Again, back to the nearest x-axis, so you can label your reference angle. Cos is adjacent over hypotenuse. Now when I label my triangle, I think of them as regular triangles with regular lengths. So that adjacent side, some people label it as negative 12 to show that you're going to the left. I like to just label it as 12 as a distance. That length is 12. My hypotenuse is 13. A squared plus b squared equals c squared. Obviously, my triangle is not to scale because if you do that, you're going to find out this side is 5. Have you seen that triangle before? That's an exciting triangle. All the numbers are nice. 5, 12, 13, no square roots. What's the first? Oh, I'll get off topic. We'll finish this question, and then I'll get off topic because I have to talk about nice triangles for a bit. So, but right now, cos of theta is negative 12 over 13. We could draw the triangle. Well, how do I find my other value? What's the big idea? What's my y-coordinate? My y-coordinate is sine. Now, if I look at my triangle, sine is opposite over hypotenuse. That's 5 over 13. And it's negative because it's in quadrant 3. Now, that last step that I did, sometimes students miss this because you figured out that you've figured out the question, but you don't actually take the time to fully answer the question. The question said, find y. As soon as people write, ooh, why is my sine coordinate? Sine of theta is negative 5 over 13. I figured it out. But you haven't done that final statement that says, my y value is equal to negative 5 over 13. They asked me to find y. My final thing that I circle should be y equals something. Okay, I said I get off topic a little bit about nice triangles. The first nice triangle you ever saw was probably the 3, 4, 5. Do you remember that one? A squared plus b squared equals c squared? No? Oh, that's like the most famous right angle triangle, the most used right angle triangle. If you ever need to build something and you need it to be square, carpenters use this all the time. They might measure 30 centimeters here, 40 centimeters here, and measure from this point to this point. If it's 50 centimeters, they know that that's a perfect right angle. And their house is not going to be the Leaning Tower of Pisa. And often you want to build things that are straight or 90 degrees, so that is used a ton. Okay? Now, we just saw that another one was 5, 12, and 13. So it's like, ooh, there's another one. Isn't that pretty? So now the question is, well, how many are there? Or is there just these two? Well, there's an infinite amount of them that work out nicely, but finding them is not always so easy. But these ones follow a pattern. So I'm going to show you the next one. 7 squared plus 24 squared, 49, plus 576 is 625, which happens to be 25 squared. So those ones work out pretty nice as well. And these ones follow a pattern. So I want to see if you can figure out some of the patterns that are happening here. And if you can figure out the next two nice ones that work out. This is amazing. So those are pretty triangles. And this pattern continues for this set of triangles. However, there's more pretty triangles out there. The first triangle that doesn't fit this pattern that's nice has an 8 on the side. 15 and 17. And that works out perfectly as well. And of course, like, this works. You can just double sides, but that one's like, yeah. Just like, that's the 3, 4, 5 just doubled, so it's not really that cool, in my opinion. I mean, it's still nice, but you could just double sides and find other ones, but they're not as exciting as when you find the original one in its lowest terms, like the 8, 15, 17. So one of the things that we're going to find throughout this course is a whole bunch of pretty triangles. And so when we do find a new one, we'll sit back and enjoy it. Oh, there's lots of math here. Anyways, we should keep going.